Now let us continue with the layers of the eyeball. We have completed in the previous session the outer fibrous coat and the middle vascular coat. Now we will start with the innermost nervous layer, the retina. The inner sensory layer or the tunic, which is a nervous layer, it contains the photoreceptor cells. They are the rods and cones. The signals pass from photoreceptors and leave the retina through optic nerve towards the brain. So you are seeing the cut section of the eyeball showing the inner layer. You are seeing this is the retina part. The retina is the innermost layer and is a very delicate structure and is adapted for stimulation by light rays. It consists of 10 layers of cells with nerve cell bodies and their axons that will be lying on the pigmented epithelial cells that attach it to the choroid. The retina is closely attached to the choroid by the pigmented layer of epithelial cells. And retina is highly sensitive to light. The layer of rods and cones are the sensory receptor cells. And this is the histological structure of the retina, which contains, in this you can observe the sclera, the fibrous coat, the vascular coat, the choroid, then followed by pigment epithelium of the retina, and then the outer segment of rods and cones and the nuclei of rods and cones, followed by the outer synaptic layer or the nuclei of bipolar cells. So this is the nuclei of rods and cones, and then which are photoreceptor cells or the rods and cones. Then this is the nuclei of bipolar cells. This is the bipolar neurons. Then there is the synaptic layer will be present. Then the third nuclear layer, which you will see, is the ganglionic cell layer, the axons of which will form the optic nerve. So we are seeing the photoreceptor layer, the bipolar layer and the ganglionic cell layer. The axons of ganglionic cell layer become the optic nerve fibers. Now coming to what is macula lutea and fovea centralis, we will learn here. So the macula lutea means the yellowish area, which is the center of the posterior part. This is the macula lutea, where the visual sense is more perfect at macula lutea. Then there is this is the macula lutea, which will be seen in ophthalmoscopic examination. Then there is the fovea centralis. What is fovea centralis? There is a depression within the macula lutea where the retina is thin and it contains only cones, and this is the region of highest visual acuity. And what is optic disc? During the cow's eyeball dissection, I have shown you what is the optic disc. This is the depressed part. And then this is the area pierced by optic nerve fibers. And it is about 1 to 5 millimeters in diameter. And it is 3 millimeters medial to the macula lutea. The central artery and vein of retina pierce in the center, and it is insensitive to light, and this is called the blind spot. In this picture of ophthalmoscopic visualization of the retina, you can observe the macula lutea, then the optic disc which is medial to the macula lutea, and you can see the blood vessels, the central artery and vein of retina and its branches you are seeing. Then coming to the interior of the eye, this is the lens which is highly elastic, circular and biconvex, and it lies immediately behind the pupil. It contains fibers enclosed within a capsule. It is suspended from ciliary body by suspensory ligament. Its thickness is controlled by ciliary muscle through the suspensory ligament. If you observe, the lens will bend the light rays reflected from the objects in front of the eye to be focused at a point on the retina for maximum vision or optimal vision. This is the only structure in the eye that can vary in its refractory power by altering its thickness. Here you are seeing it thin and the light source is from distant object. And in this picture you can see that it is thick when the light source is from the nearer object. And this is the focal point. When the ciliary muscle contracts, it moves forwards, releasing the pull on the lens, and it increases the thickness of the lens. That's what you are seeing in this picture. So the lens must change its shape to focus for near objects. The nearer is the object being viewed, the thickness of the lens will be more to allow focusing the image. The eye is set for a distant vision of more than 20 feet. Coming to the abnormalities of eye with reference to focusing the light rays. The correct focus is called emmetropia, which is normal. Then, in case of myopics or in near-sightedness, this is the focusing of the light rays on the retina in the normal uncorrected person. And how this defect is corrected is by giving them the concave lenses. Then presbyopia and hypermetropia. We will see the hypermetropic, which is a far-sightedness, and how the light rays will be focused in them, and how it is corrected by prescribing convex lenses. The other conditions are presbyopia, which is age-related failure of lens to accommodate to the objects. Then there is condition called astigmatism. It is distorted vision due to irregular shaped lens or cornea. The other condition of importance is the color blindness, which is a genetic defect that causes dysfunction of cones. Now, let us learn a bit about the accommodation of lens for near vision and distant vision, and it is simplified in the form of a table for your reference. So in near vision, what happens is the ciliary muscle contracts and the ciliary body pulls forwards and inwards, The tension on suspensory ligament of lens will be decreased and the lens becomes more thicker because of elasticity and the pupils constrict. For far vision or distant vision, the ciliary muscle relaxes, the ciliary body returns to its resting position, that is backwards and outwards. The tension on suspensory ligaments will be increased. The lens becomes thin because of its elasticity and the pupils will dilate. So compare both the diagrams and the tables for understanding. We can look at these pictures for understanding what is myopia, what is hypermetropia, and what is astigmatism. In the case of myopia or nearsightedness, focus of light is in front of retina. The eyeball is too long or lens is too strong. The distant objects will be blurred, and this is corrected by prescribing a concave lens or negative lens to reduce the refractive power. In the case of hypermetropia or hyperopia or far-sightedness, the focus of light is beyond the retina. The eyeball will be short or the lens is lazy or amblyopia. The near objects are blurred and it is corrected by prescribing convex or positive lens to add refractive power. Then in case of astigmatism, the cornea is irregular in shape or the lens is curved. Eyeball is irregular in shape. The objects are blurred or distorted and it is corrected by asymmetric lens to compensate for the asymmetry of the eye's lens. Then what is cataract? It is foggy spot on the lens of the eye. See, the lens is clouded by cataract. And it can cause poor vision, double vision and blindness. Coming to the interior of the eye, the anterior segment, it is the space between the cornea and the lens and it is incompletely divided into an anterior and a posterior chamber by the iris. Both the chambers contain the aqueous humor secreted by the ciliary processes. So what is aqueous humor? There is continuous production and drainage of it by the ciliary processes. The intraocular pressure, though it is produced continuously, is fairly constant between 10 to 20 millimeters of mercury. If there is an increase in this pressure, it causes a condition called glaucoma. The function of aqueous fluid is it supplies nutrients and removes waste material from the transparent structures in the front of the eye that have no blood supply. It is the cornea, lens and lens capsule. The posterior segment is behind the lens and it will be filling the posterior segment of the eyeball, and it is called the vitreous body or vitreous humor. So regarding the production of aqueous humor, the aqueous humor is a product of ciliary processes. You can see the ciliary processes, and then it flows through the posterior chamber, and from this chamber through the pupil it reaches the anterior chamber, and at the sclerocorneal junction it drains into the scleral venous sinus or canal of Schlemm, where the aqueous humor is reabsorbed. And if there is increase in intraocular pressure due to the buildup of aqueous humor, that condition is called glaucoma. Coming to the vitreous humor, it's a soft, colorless, transparent, jelly-like substance which you have seen in the cow's eyeball dissection. It is composed of 99% water, some salts and mucoprotein. It maintains sufficient intraocular pressure to support the retina against the choroid and prevents the walls of the eye from collapsing. It keeps the shape of the eye because of the intraocular pressure, and which is exerted by this one, and also the aqueous fluid. So the aqueous fluid and the vitreous body are responsible for maintenance of shape of the eye, and it remains constant throughout the life. The blood supply of the eyeball. The ciliary arteries and central artery of retina supply the eyeball. These are branches of ophthalmic artery, which is a branch of internal carotid artery. The venous drainage is by number of veins, including the central vein of retina, which empties into deep venous sinuses. The central artery and vein are enclosed along with the optic nerve that is entering at the eye at the optic disc. Then coming to the optic pathway or visual pathway. So for understanding this optic pathway, we have learned the anatomical structures and especially the layers of retina. So the rods and cones of the retina, from where the visual information starts, and it traverses through the bipolar cells of retina. So this is the pigment cells. Then you are seeing the rods and cones. From there, the information goes to the bipolar cells of retina, and from this the information reaches the ganglion cells of the retina. From there starts the optic nerve from the eyeball, and it reaches what is known as optic chiasma, the interpeduncular fossa at the base of brain. So the optic chiasma is formed by the decussation of the optic nerve fibers. From the chiasma starts the optic tract, which is also in the interpeduncular fossa. From the optic tract, the information will go to a structure called the lateral geniculate body, part of thalamus. From the lateral geniculate body, it will be transmitted to the primary visual area in the occipital lobe of cerebral cortex, and also to the superior colliculus of midbrain, to the motor neurons that control the eye muscles. So this is the optic or visual pathway. So in the visual pathway, you will come across the cones, the bipolar neurons, the ganglionic cells of the retina that will form the optic nerve. The optic nerve you can see in this picture. So going from the nasal part and temporal part of retina, going towards the optic chiasma, where the fibers from the nasal part are crossing in the optic chiasma, whereas the temporal fibers, they travel uncrossed and they pass through the optic tract and then to the lateral geniculate body, which is the nucleus of the thalamus, and from there starts the optic radiation, which will go to the primary visual cortex in the occipital lobes. So that is the visual pathway. So now we have understood the various layers of retina, and then how the visual information travels through these layers, and it is reflected onto the visual cortex for appreciation of the image.